spent far too much time on the internet. When one happens to spend enough time on Wolfram Alpha, some may notice some very interesting things. What, 3 Planck units? End up being 1 of something? Well, you all know what that means. We conjecture ahead.
Although this is going to be weird, and it's going to be about a different.
Title of the conference was something like "Ground Truth" or "Turtles All the Way Down," and so it seems as though there's one Ruliad. I don't think it rules them all, and it might be just hyper-rulial turtles all the way down.
Yes, it's on the back of an infinite number of hyper-rulial turtles.
Various people are commenting on the outrage of hacking the universe on a MacBook Air.
Hey guys, what's going on? Memes here. Welcome, Kali. I apologize. I've been meaning to slide up into yours and Brad's DMs. I'd like to have a cosmology talk with you because I think we're all kind of talking about the same thing. I think you're going to like Thad's upcoming video. But the subject of today's stuff and things is the Ampere, because this is one of the things that I happened to learn from Thad a while back. This happens to be a component in basically the factorization of the minimal model. Basically, I colloquially refer to it as the HF8 model. But essentially what happens is you take some of the Planck units, basically these fundamental things that we derive after we measure all these other stuff and things. Apparently, there seems to be minimums and maximums for time, space, charge, mass, and temperature. Why? Because we can. We're working on it. But I think it literally is because we can. But here's the thing. When you take the Planck mass and you multiply it by the Planck length, and then you divide it by the Planck charge squared, you get that's literally what I did. I type it in there. I threw the brackets there because we're doing multiplication, division. So yeah, math stuff. Coincidentally, it comes out to be a very interesting number. 1 times 10 to the -7 kilogram meters per second squared ampere squared. What the heck is that? These are the units that come out when you take mass, length, and you divide it by charge squared. The other fascinating thing is, wait a second, mass, length, we put those in. Time and current, I guess those are factors of charge. Time and current. We'll get into that in just a moment. Kali, I think you're right. We'll get to it. That's why I want to have the discussion with you, because I'm still learning. But this number happens to correspond to be 1 ampere constant, which also happens to coincidentally be the Savart constant. But when we click on amp, actually no, let's go to Ampere. There's our friend Wikipedia. Links are of course in the doobly-doo. All right, where are we? The Ampere symbol A, often shortened to amp. It's a symbol A. Amp has more characters than that. Oh, they're referring to that. Okay. It is a unit of electric current in the International System of Units, SI. 1 ampere is equal to 1 coulomb, or 6.241509.074 times 10 to the 18 electrons worth of charge. That seems to be a fair bit of charge, I'd say. Worth of charge moving past a point in a second. It was named after French mathematician and physicist André Marie Ampere, considered the father of electromagnetism, along with Danish physicist it's Christian Ørsted. Oh, what's this? The 2019 redefinition of SI that, according to Thad, happened to have about a 3.5 sigma shift in some areas. So it's like maybe there has to be some wiggle room depending on what we're doing. I think that is a mole. No. Mole, I think, is 10 to the 26 for some reason. I'm just recalling back. Oh God, like 20 years ago, over 20 years ago in chemistry now. Wow. The moments you feel old. It's all right. But okay, as of the 2019 redefinition of the SI base units. The ampere is defined by fixing the elementary charge E to be exactly 1.602.176.634 times 10 to the negative 19 coulombs, which means an ampere is an electrical current equivalent to 10 to the 19 elementary charges moving every 1.6 yada yada seconds, or that whole big number there, elementary charges moving in a second. Prior to the redefinition, the ampere was defined as the current that would be needed to be passed through two parallel wires, 1 meter apart, to produce a magnetic force of 2 times 10 to the negative 7 newtons per meter. That's also very interesting. Why is that the case? Magnets. How do they even work? We're getting closer, I claim. But yeah, I mean, it's just so exciting. It's like from the days of Faraday at the Royal Institute. Hey, there's a magnet. There's some iron filings. Look at the cool things. And now we have like computer simulations and all that jazz for that. Again, we're getting closer, I think. The earlier CGS system had two definitions of current, one essentially the same as the SIs, and the other using Coulomb's law as a fundamental relationship with the unit of charge defined by measuring the force between two charged plates. The ampere was then defined as 1 coulomb of charge per second. In SI, the unit of charge, the coulomb, is defined as the charge carried by 1 ampere during 1 second. See, this is the interesting thing, because a lot of times we're like, oh, we got science and everything, and then you realize, like, wait a second, physics and chemistry, it seems to be a wee bit of a difference there. You're like, how could there be a difference? And that's why we came up with, like, the AMU, the atomic mass unit, to kind of unify things. What'd we do? We took some of those pretty stable that we got a bunch of, carbon, divided by 12, because it should... 6 protons, 6 neutrons. You should have your 6 electrons there. It should be a fairly... We'll get into that once Thad releases his video with the equations instead. We'll go through it. But so why am I talking about this? Because you look at that. Okay, let's go back to our dimensions. Mass and length. Okay, so we got length, and then if the coulomb is essentially the elementary unit of charge. Charge is, yeah, what were they just saying? The current divided by time or something like that, or per unit of time. It's defined as 1 coulomb of charge per second. Okay. We got basically 1 coulomb of charge per second. Oh, sorry. Spoilers. Yeah, so when we click on that, and go over here. The ampere constant, yeah, we got those. Look at them, have a 1 there. How many digits is that coming up? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Oh yeah, one of the other things, the reason this is interesting, because apparently when Thad was like going through the constants, he's looking right around 7 decimal places, sometimes a little sooner, sometimes a little later. If you keep on trying to use the same units again and translate, they get a little wonky. Now, I'm not saying that's one of the reasons why they did the 2019 redefinition of SI. It may explain a lot, though. Just speculation on my part. If you're going to have a coherent set of units, you want to be coherent and line them up to the best of your knowledge and measurements, right? Otherwise, we're just like, here's some numbers. Let's just know what we want. I mean, you can totally do that. I'm not sure it'll work. Maybe you'll get lucky. God, maybe I'm one of the lucky sons of guns in the world. But the interpretation is magnetic permeability. The magnetic permeability of free space, of stuff and things. Is there actually ever a real vacuum there? Because we're like, in a vacuum. But there's stuff going on. Okay. What's going on? Quantum fluctuations. Well, I don't know. Welcome, Bone. Good to see you, my friend, in kitty form. But yes, we're just talking about magnets, how they might work. Basically, you get this fundamental unit, so the ampere. It's kind of like we call it the amp over here. It's like, oh, the voltage, you have all these pictures. Tesla's touching this thing. There's 1,000,000 volts electric. How is he doing that? It's like, okay, well, the volts is the bandwidth is something that still kind of confuses me. But the ampere is the unit of charge, because apparently, according to one of my electrician friends or whatever, it was like, yeah, I think like an amp can actually kill a human. It depends on the speed and the amount that it goes through, but yeah. But we got this, and it curiously that comes up with you just do this division by very elementary units. Literally just type in blank mass, blank length, throw in some brackets, divide by the Planck charge squared. Because it's this beautiful thing. And the magnitude of the answer just happens to be 10 raised to the negative 7. Right around that line, when you start looking at the constants of nature, at least before the redefinition of SI, things kind of start to get wonky. And that's where it comes into that construction of the minimal arena, or the HF8 model. You have a primary action. That action may be 1. You have the primary action, and then you multiply it by its boundary conditions. So in this case, we have mass, length, time, current. So that just happens to translate mass, length, charge, current. Depends on what it is. Speed of light. What's that? Oh, I don't know. Blank time divided by the Planck length. Unit of time divided per unit of distance. Okay. I will do that at some point, the derivation. I'll actually do like a real video. It's fascinating. But what else you do is, all right, you have a primary action. Multiply that by the boundaries, and then you multiply that by the terminal action, because we're assuming if you're going to be modeling something off of like the hyperbolic figure 8 knot, a Giesecke manifold, it's literally a Kleinian thing. You literally have that inversion within it, but that's going to happen at a particular magnitude. And it just also happens to line things up and actually has very, very interesting results. And it looks like there might be a realm of continents, so say, of constants. That actually sounds really cool now that those words come out of my mouth. But I'm sure if that had said it when we were at the monastery. But what happens is you have a terminal action. Primary action, boundaries, terminal action. And that terminal action is 1 plus whatever the action is. Okay, maybe it's 2 pi, maybe it's 4 pi. And then you multiply that by this right here, 10 to the negative 7. And coincidentally, when you start lining things up, they seem to agree with a lot of the measurements. It's also a method of quote-unquote treasure hunting. Because we already have all this data and everything. Why wouldn't we use the data we have? And I think it starts to actually tell a story of what may be going on from a geometric perspective. Or at least I'll claim that. Just the magnetic constant and big G. Oh my God, this is so beautiful. The videos. I should probably actually start linking them when I start mentioning them. But yeah, hey, Whitechapel. Thank you for joining, my friend, as well as Universe. Good to see you guys. Good to see you guys. No, we're just wrapping up. Basically, this was one of the things where, at least in the models I've been playing around with, and kind of the whole SI redefinition. Go over here. Oh, what's this? Oh, okay. So we got the second, the meter, the ampere, the Kelvin, candela, kilogram. Okay. Kilogram, second, mole, mass. Oh, wait. Oh, but that's cool. Is that Coulomb? No, they're doing it that. I don't know. All you really need are 5 of these. I'm pretty sure with 5 of these, you can get back to the other things. So, as we can see. In 2019, 4 of the 7 SI base units, specifically in the International System of Quantities, were redefined in terms of natural physical constants. rather than human artifacts such as the standard kilogram. Basically, just that bar of, what was it, palladium or platinum or something that's locked up in like France and a couple of these things. We're going to base our measurements on this. Why? Because we can. Or you just use like the constants of nature and stuff. I don't know. Effective the 20th of May, 2019, the 144th anniversary of the meter convention, the kilogram, ampere, Kelvin, and mole are now defined by setting exact numerical values when expressed in SI units. The Planck constant H, elementary charge E, the Boltzmann constant KB, the Avogadro I wanted to say avocado, the Avogadro constant Na, respectively. The second meter in candela had previously been redefined using physical constants. The four new definitions aim to prove SI without changing the value of any units, ensuring continuity within existing measurements. There we go. All right, so they proved it, yada, yada. Okay. So that's cool. Oh, yeah, and then when we go over here, here's 1 coulomb. It's that big number of elementary charges, which, again, just at least to me, hold on, let's reload this. Now, again, I am just a dude on the internet. I am not a professionally trained physicist nor mathematician, although I have had the privilege of talking with some really smart folks. I see this number over here, 2.998, that's 10 to the 9. That looks a wee bit familiar. Let's get some more digits. Wait. No. Hold on. ESOs, blah, blah, blah. Let's do static coulombs. Okay. Wait a second. I did this the other night. I've just got this tab open. Hold on. Oh, yeah, no, let's just click on it. We'll do this. All right. Wait, no, not the image. But basically, when you go out, that comes out to be at least the numerical value for the speed of light and, like, I think an extra additional digit. It just happens to be an additional power, which is interesting. These are the thing. Hold on, let me go up to coulomb. So 1 coulomb. There we go, more digits. More digits. Here we go. Okay. So we got these, 2.99. Let's go over here. Speed of light. 299. Hold on. They give us, we should have some more digits. We have at least 9. More digits. All right, we're cut off. All right, so speed of light, meters per second. 299. 792. 792. Oh. 458. 458. Huh. You giving me more digits? Oh, it's cut off there. That must be 1, 2, 3, 4, 5, 6, 7, 8, 9. 9 digits for the speed of light. Oh. This also happens to be 1, 2, 3, 4, 5, 6, 7, 8, 9. And then there's a 0 there. Huh. 1 ampere. That's pretty cool. Now again, I'm sure these are all just coinky dinks here. But if it didn't happen to be a coinky dink, I think this is a pretty neat thing. And I'm sure there's a lot of folks that know about this and everything, but when you just start looking and you happen to see that there happens to be a very specific number, especially it's like, okay, that hits an ampere, okay, we can get that, but the magnitude, 10 to the negative 7. I just find that very interesting. I think it may help explain a lot, but that's all I got for right now, folks. Thank you all for joining. Take care of yourselves, everyone. It's a wacky and wild world out there, but I think there's some real good stuff coming. So, peace out, everybody.
Have you guys checked out the Memes of Destruction's channel? He's an interesting dude. I like him.